Welcome to Team PacmanZero. In this video, we are going to introduce technicals for our project. We implement 4 agents. 3 of them are corresponding to the specification, which is A star, MCTS, goal recognition techniques, and another algorithm related to reinforcement learning. The first algorithm is A star. This is the algorithm that we are most familiar with. We set the goal state and use A star to find the promising route, recalculate the route when ghost detected, record the actions and apply them. In A star, it's hard to detect the blind alley and assign the most relates to ghost, and we can improve by using more realistic heuristic function. Pac-Man game can be considered as a maze problem. In this case, it is a little bit hard to use offline algorithm to learn as it will be a great workload to learn all possible mazes offline. So we will try an online algorithm which is Monte Carlo tree search. We are mainly for the follow MCTS steps, randomly choosing actions to select node to expand, simulation 30 times for each action, and get total, evaluate reward as QSA, and choose action with best QSA. The biggest challenge we made is to balance the weights between different features and also avoid the ampli value. For improvements, we can apply UTB1 in node selection and we can use DFS to detect blind value. Goal recognition design is quite simple and easy to be understood. Applications of goal recognition design can be found in many problems where goal recognition is useful and quick performing is required, such as intrusion detection. In this problem, we use technology to play as the defender. Our target is to kill and find the opponent agent. To do this, we set some fixed point in our own side and ask our agent to randomly patrol between these points. Meanwhile, we have a dynamic feedback regulation that if our food is eaten, our agent will find the nearest way to search that position. Moreover, if we detect our opponent, we just chase after him. The biggest challenge is that it won't have a good performance if the maze is too large. At present, we use maze distance and don't have weights. We can combine it with A-star search. When we check the food loss, give the weight of those different conditions to see which one is more urgent. We do the last algorithm is because we want to have a try about the latest technology. For this algorithm, all technicals used in the algorithm are listed on slides, including independent deep recurrent double dueling queue network for each agent, concurrent experience replay memory, and a shared reward function. And we use 12 images as network input to train our agent. At the beginning, there are some spatial conditions and limits for this project. After doing some academic research, we found a promising method to train our agent, which is shown on the top of slides. However, it needs long time of training and sensitive to changing maps, so we cannot guarantee the performance. For the reward function, currently we design on our reward function in this game. The rules are listed on the slides. The spatial structure of the recurrent queue network is shown on the slides. However, for the slides results for this method, due to time constraint, we cannot finish its training in time and the performance is poor compared with other methods. If we have more time, as we expected, it can perform better.
In this part of video, we can see that the A-star offensive agent detects the ghost and gets out of the dead end in time, and after eating the capsule, it continues to seek food and ignores the ghost. In this video, we can see that the red agent implemented by MCTS, after detects the ghost, avoids the dead end and returns to the safe position quickly, then restarts to the next food. From this piece of video, we can see that the defender can receive the feedback about the food which has been eaten, then moves towards that position and finally kills the Pac-Man. This is our presentation about the Pac-Man contest. We are Team PacmanZero. Thanks for listening.